Hello, welcome to my video on a kind of a specific exponent algebra example that we see throughout grade 8, grade 9 and beyond in applications and so on and so forth, but it's always misunderstood and done improperly. So it's negative 5 in brackets to the power of 3 versus negative 5, no brackets, to the power of 3. So have a look at the left-hand side. What this means is that our base, it's within the brackets, that's what's being multiplied by itself twice. So negative 5 in brackets multiplied by negative 5 in brackets multiplied by negative 5 in brackets. Working this through, negative times a negative gives positive 25, and multiplied by a negative 5, positive times a negative, the answer being negative 125. On the right-hand side, notice that the 5 and the negative are not in brackets, meaning that the base in question here is just 5 and not negative 5. So, to properly solve this problem, we're going to take 5 cubed, 5 to the power of 3, and write this out first. Remember, in BEDMAS we do exponents before multiplication or subtraction, and we have 5 times 5 times 5, 5 cubed, and then we're going to take on that negative. Working this one through, again, BEDMAS, we multiply first before we subtract or apply the negative. 5 times 5 times 5 is 125, with the negative tapped on at the end. So we got the same answer in that case. Let's look at example 2 though. It might be a little bit different. Here we have negative 3 in brackets raised to the power of 4 versus negative 3 not in brackets raised to the power of 4. So on our left-hand side, we're going to have a base negative 3 to the power of 4. Now, the key again here is that the negative 3 is in brackets. Okay, the negative is part of the base, as indicated by the brackets. And this translates into negative 3 in brackets, multiplied by negative 3, multiplied by negative 3, multiplied by negative 3. Working this through step by step, we've got a negative times a negative, which gives us a positive 9, multiplied by negative 3, multiplied by negative 3. Our next step, working left to right, all multiplication, positive 9 multiplied by negative 3 gives us negative 27, multiplied by negative 3. And then our final step, a negative times a negative, yields a positive 81. Now, positive 81, we're going to compare that with the right-hand side, where we have something a little bit different. Again, the negative is not in brackets, so therefore is not going to be considered part of the base. The base will just be 3. And we'll see how this pans out once again. So in calculating this, we're going to have 3 as the base, so 3 raised to the power of 4, we'll write that out. And then at the very last step, we will be tagging on the negative at the very end. Now we already know what 3 times 3 times 3 times 3 equals. It's 81. You can go to your calculator and double check that. The main point here is that they're all positive numbers. The bases are positive. The base 3 is a positive number. So positive multiplied together, doesn't matter how many there are, the answer is going to be positive as well. So we have 81, and then we tag on the negative at the very end. So the answer on the right-hand side is negative 81 compared to the left-hand side, which was a positive 81. Key distinction, key difference that often is misunderstood. Thanks for watching, and we will see you in the next one.